Welcome, welcome, welcome. So, this is actually our last class before exams, as next Monday is the civic holiday weekend. We won't be having class. So we're going to do some exam review. So this is going to be in the form of a review session. I will be publishing a mock exam test, which you're free to print out and complete on your own time. Since we only have the one class, we're not going to do it in class, although I would be happy to answer any questions that you guys might have about, about that material. It's just a few practice problems. The thing is actually composed of, well, if you were with us in the winter term, you might find it a bit familiar. But it's essentially composed of questions which I had written to be included in previous exams, but got cut for one reason or another. So I put them all together into a document. It's a little light. It's not quite as long as an actual exam would be, but it's still something. It should give you an idea of the sort of breadth and scope of questions. Not the exam questions, of course, but exams questions sort of in a general sense. So, let's talk about the exam itself. Does anybody have any questions about the exam? No? Well, you're not a very curious bunch, are you? No questions at all? Good morning. Well, I told you the day and time for the exam. Good. I told you about the crib sheet. No? Okay. So, I am going to be permitting one 8.5 by 11 double-sided crib sheet. It's a piece of paper upon which you may write anything you please, anything at all, up to and including example code, test example, test examples. It's like, you're not going to have the actual exam questions, so you're not going to be able to put the solutions to the exam questions on your cheat sheet. That would make it a very, very easy test. But you will be able to have some memory aid in the test. Please use it appropriately. Come on in. So, I should probably have, how many of you have written an exam with a cheat sheet before? Pretty much everyone except you?
Oh.
All right. So, I will reiterate my advice for using optimal use of a cheat sheet. So you should view the cheat sheet not only as in-test reference, right? You shouldn't just view it through its utility during the test itself. The cheat sheet is actually the best studying that you will do in preparation for the exam as well, as long as you don't cheat on your cheat sheet, as it were. So, there are good approaches and bad approaches to a cheat sheet. A bad approach is to take large sections of your notes, shrink them down to size 2 font, use a magnifying glass during the test. That's a bad way to use a cheat sheet. Although, in theory, all of the information will be there on your cheat sheet, it doesn't help you to any degree on anything other than surface level knowledge questions, right? It won't help you on understanding or application questions, and it's unlikely to help you with any coding problems as well. Not to mention, it's not even particularly good for what you think it's good for, because all you're doing is you're taking vast quantities of information, compressing it down, getting it on 2 pieces of paper. What you are essentially doing is you're making it very difficult for you to actually find anything on the cheat sheet. Remember that an exam is, of course, a time-limited exercise. You only have so much time. So if the information on the cheat sheet is not easy to find, then that's a problem, right? You're wasting time trying to find the information, which, you don't know if the information is going to be helpful until you start reading it. So, what are you going to do? Read through your whole cheat sheet, every question? Right? It's a little bit silly. So, the best way, in my view, to construct a cheat sheet is to make it a point form summary of the important elements of the course, including code examples. That's what I would recommend. Now, you have to be careful again, because it is of paramount importance that you yourself are the person who puts the cheat sheet together. If your inclination is to collaborate with people in the class to create said document, my recommendation is this: make your own independently, and then afterwards compare it to your friends to see that you thought the same things were important, right? What you should not do is you should not do, okay, you do chapters 1 and 2, I'll do chapters 2 and 3, or 3 and 4, etc., right? That's something you shouldn't do. Don't break the course up like that, because effectively you will have only studied the chapters that you summarized, right? You want to study the whole course. The whole course is going to be on the exam. Yes. So, and even more especially, don't allow someone to just do the whole thing for you. Hey, can I use your cheat sheet? I didn't have time. It's like, yeah, well, is that more helpful than not? Yes. It's better than not having a cheat sheet at all. But are you making full use of the opportunity? No. Right? Does that make sense so far? And of course, the absolute worst thing you could do is have the infernal chatbot summarize the course content for you and put that on your cheat sheet. Because, not only are you robbing yourself of, your best opportunity to study by using AI, you're also robbing yourself of precious human interaction, which we get so little of these days. So, yes. In summary, cheat sheets. Any questions?
Is that like an 8.5 centimeter paper?
Inches.
Oh, inches.
Yeah, just one piece of standard A4 printer paper.
I thought it was an index card.
Yeah. Oh, no, it's not an index card. No, it's just a piece of printer paper.
Okay.
Yeah. You're just not allowed to bring a sheet of Bristol board. Okay, sometimes some people ask me, is there anything I'm not allowed to put on my cheat sheet? And I say, Post-it notes. The one thing you're not allowed to have on your piece of paper is more paper. Also, I don't want any of this funny business of people who print off 2 pieces of paper and glue them together or tape them together. I don't want to see it. Listen, if you're going to do double-sided and you're going to print it off, learn how to use your printer. If it takes a couple of tries to print front and back, then you've wasted a couple of pieces of paper well. Because I don't want to see any of this nonsense. Alright, I don't want any cavities that you can hide other pieces of paper in. 1 piece of paper is all you get. You understand me? Alright? So, any other questions? Had a couple of people come in a bit later, so this is a review session. We don't have class next week because of the civic holiday weekend. So this is our last class before the exam. So if you have any questions about the exam, now's the time to get them out. Get them out and aired in the bright sunlight of me actually knowing what's going on. So, all right. Very good. So we should then discuss exam coverage. Exam coverage. Well, how about you tell me what's gonna be on the exam? What are some topics that we covered? Yes?
Bootstrap.
Bootstrap. Sure. Bootstrap has been a major theme that has run through the entire course. I was about to say not one assignment has been without it, but A4 was, like I said, maybe not as much, but yes, Bootstrap is definitely something we talked about this semester. Anything else?
SVG.
SVG? Oh yeah. SVG was one of the big major 4 topics that we covered. What about SVG particularly? I'm going to change colors because I think that. Is this better? Oh, that's much better. Okay, this is my marker now. What about SVG?
Creation, animation, mouse over events.
Creation. What was the second one?
Animation.
Animation. And?
Mouse events.
Sorry, one more time.
Mouse events.
Mouse events, yes. Very good. Anything else? There's a big topic in that topic. It's actually the entire point of that topic. Yes?
Is it removing objects?
Yes, object creation and destruction. That was actually the entire reason that the SVG unit was cooked up in the first place, was to give you a kind of a nice little juicy, medium for learning how to do proper object-oriented object creation and destruction in JavaScript. Okay, what other topics do we have?
Document object model.
The document object model. Yes. Anything particular about it? structure. I would add to that manipulation. Reading values from it, writing values to it. Any other topics? CSS? Well, why don't we just sneak that one on the end here? Fair enough? Anything else? What was the topic we just did? Yeah. Fair enough? Anything else? There's one we've touched on, but it was also kind of a major topic. Module 2, the one before SVG. Well, CSS animation is, we'll sneak that one in here as well. That's also something we did. No, but I'm thinking of something else. We had module 0, where we talked about HTML and how packets are passed and that sort of thing. We had module 1, where we talked about CSS and Bootstrap and CSS animation. Then we had module 2, which was our introduction to the language. Which language? JavaScript. So, fairly early on in that, there was a discussion of the JavaScript language, how it works, how it differs from the other languages that you've learned so far, some of its peculiarities and eccentricities. We also talked about events. Event-driven programming. That was a fairly major one. Among those, what types of events did we talk about? What was the first event we did in class? I wasn't even teaching the first half, and I can tell you what the first event we did was. Oh, I just heard it.
Click event?
Click event, there we go. So, mouse events. Mouse events in general. And I would throw in timing events as well. Is that enough? Does that look like the course to you guys? Well, maybe I'll just sneak the camera over there and make sure that... There you go, there's our topic list, everybody. All right. So, where do you guys want to start? I'm not sure that we'll be able to get to all of this in the course of the, how much do you have left in class? We have 2 hours and 40 minutes minus 15, 2 hours, 30 minutes minus 15 minutes for this review session. So prioritize the things that you want to see. Who's got a topic? Yeah.
Start with JavaScript.
Start here. Start with language topics, and then go to, just go through?
Yeah.
Yeah, okay. Sounds good. So, JavaScript. JavaScript is a language that is based on an interpreter, right? This makes it very different from compiled languages. One thing that's very important to know about JavaScript is how the browser loads it in the first place, right? So, when the browser loads an HTML file, it parses that file starting at the top and going to the bottom. It loads each component as it encounters it, right? So, JavaScript is executed as soon as it is encountered in the browser. This is why it's necessary to either defer the script or to use a window load event, something of that nature, if the script is attempting to access DOM elements. Where do script tags go?
Below body tag or HTML?
Well, if you put it below the body tag, it certainly will execute after the body of the page has been loaded, but it's not considered good form to load your JavaScript at the foot of the page. It is considered good form to load your JavaScript the same place you load your CSS files. Where do you load your CSS files?
Head.
In the head. Yes. So this kind of puts us in a slight dilemma, right? While we're in the head, we have not gotten to the body has not been loaded. If we attempt to pull references to things out of the body, again, the body hasn't been loaded yet. That's why it's necessary to put the defer tag in. What does the defer tag do? Anybody? Try not to look it up. Yes?
It makes it so it loads after the whole page is loaded.
It makes it so that it loads after the whole page is loaded. Yes, very good. It defers until the page is loaded. Essentially, JavaScript is an evolving language. It was seen that, oh, we really do need this window load event. Maybe we should put something in the language so we don't need it anymore. And the defer tag was born. So, good. Wonderful. So let's discuss JavaScript as a language. How does JavaScript's type system work? What kind of typing do we have in JavaScript?
It's a weakly type language.
It is a weakly typed language, that is true. There's one other as well. There's another feature of its type system. Not string type. It has string. Strict type? Well, when we talk about weak typing, we will talk about how to enable strict typing. But there's one other thing. These two are often confused for each other. Static and blank. What's the blank? Dynamic. Static and dynamic are opposites. So we also have dynamic typing. So, JavaScript is a weakly typed language and a dynamically typed language. So, let's first discuss what it means to be weakly typed. Can anybody offer a definition? What does it mean for something to be weakly typed?
You can change like integer variables to like string variables easily.
So you remember how I said that these two are often confused? That's actually dynamic typing.
Oh.
Yeah. See? It's a good thing we're doing a review, right?
Yeah.
So dynamic typing, we can change types on the fly. So for example, with dynamic typing, if I have let x equal 5, and then I assign to x hello, in Java, Java is a statically typed language. In Java, would this be legal? Not on your money. Java is very strict about not assigning the wrong type of thing to the wrong box, right? So, in Java, that would cause a compiler error. Not so in JavaScript. In JavaScript, the type of x changes to accommodate the type that you're putting into it. Dynamic typing. Does that make sense? Okay, very good. But we're still wondering what weak typing is. You want a hint? It's all about equality operators. It's all about the fact we have two equality operators. What are they?
Typing, please.
Say that a little louder.
The loose of the strict. No, the weak and the strict.
Weak and strict typing, yes. So in JavaScript, there are two equality operators. You have this one, which is of course the one we all know and love from Java and Python, and pretty much every single programming language uses that actually. But then we also have this strange organism, the triple equals. Can anybody tell me the difference between double and triple equals? Yes?
Is it the memory address and then the data that's stored inside the variable?
It's not quite memory address, although that's a good guess. That's a very Java guess. So, this guy is weak typing. This one is strong typing. right? You can also call it strict typing. So the difference is weak typing will attempt to perform some type conversion before comparing values. So in Java, true or false? In Java, true or false? How many people think true? How many people think false? Good. That is false. Very good. Why is it false?
The string hash.
Yes. In fact, it's so false that I think depending on the conditions and perhaps depending on in other languages, maybe in C#, that's so incorrect it may even cause a type error because you're comparing things of two different types, which you shouldn't do in a strictly typed language, in a statically typed language. However, in JavaScript, true or false? That is true in JavaScript. JavaScript takes those values and it attempts to type convert them before it performs equality comparison. Don't ask me what it converts it to and in what order. These are mysteries known only to JavaScript graybeards. But this is an example of weak typing as opposed to dynamic typing. Does that make sense? So JavaScript is not the only weakly typed language that you will use. When you folks get to server-side programming, if you haven't done so already, you will find that PHP is a weakly typed language as well. You will also need to know the difference between those two forms of equality in PHP. One language, which you've seen already, Python, right? First, is Python statically typed or dynamically typed?
Dynamic.
It is. Python is dynamically typed. Is it weakly typed or strongly typed?
Strong.
It is strong. You've never heard of a triple equals in Python. So, if you want an example of a language that's a little bit of a middle ground between these two positions, right? You've got Python. Python permits dynamic typing, but it also requires strict comparisons. Make sense? Good. Let me think, is there anything else that we need to talk about for Java? Oh, I'll throw one more thing on here. Functions, specifically anonymous ones. Does anybody need this? Can I, okay. I'm going to throw one more thing on there. So, variables. Variables in JavaScript. There are 3 ways of declaring variables in JavaScript. What are they? Let is one of them. What's another one? Yes? Const, yes. And one more? Var, yes. So, let's pick on const first. What does const stand for?
Constant.
Constant, yes. So, a couple of things are important about constants. Number one, after their creation, you cannot modify them. This is actually a good thing, right? If you can't modify them, then you can't get into trouble when they enter strange states. And global variables entering strange states is a cause of some of the worst bugs you can imagine. Very difficult to replicate bugs. Whenever you have any value that you need, that you don't need to update or modify, it makes sense to declare it as a constant. In fact, a good programmer will almost default to constants over regular variables, particularly in the global scope. Make sense? So, what's the difference between let and var? This is sometimes taught as let is for local variables, var is for global variables, but that's not quite true. Sorry, let me just look it up for a moment. I forget myself. Oh man, I knew this like 3 months ago. It's terrible having your brain get old. Ah, yes. Good, okay. That's correct. I remember that now. So, it is true that the scope of a var is a bit larger than the scope of a let. But here's the difference. Let is block level scoping. Whereas var is function level scoping. Do you folks need a refresher on scoping, block and function level? Well, it is a review session, right? So let's say we have a function. Let's say that within this function, we have an if statement. And let's say that within this if statement, we have one let declared and one var declared. So the scope of a variable is the segment of the code where that variable is defined. Var is function, not functio, function level scoping. Var uses function level scoping, so the thing that limits its scope is the enclosing function. So var is defined anywhere in this red region, the domain of y. This is also sometimes called a variable's domain. Does that make sense? However, x, as declared here, x is declared using a let binding. Let bindings are block level scoping. This means that it only binds as far as the closest enclosing curly braces. So our poor x variable is limited to only that much of the code. That is as far as x is defined. Does that make sense? So technically, if you want to get right down technical, it's actually only defined in here. There's one kind of there's one caveat to this, which you may find interesting, and that is application to the for loop. So in a for loop, oh, I did Java. There we go. So, with a for loop, technically, if you put a let here, its scope would be inside of the for loop, but strictly inside of the for loop. J would not be defined within the loop condition. Interesting, right? However, if the variable has been declared right here, then the scope is just slightly larger. The scope is large enough to include the condition test, but no larger than that. Does that make sense? I mean, it wouldn't, like, if that weren't the case and this variable only had like the green level of domain, it would mean that for loops were kind of non-functional, right? Because you know, the whole point of this statement is that you're declaring a loop variable. If you can't use the loop variable to test to see if the loop is finished, what's the point in the loop variable, right? So that's kind of a one little edge case there. Does that make sense? Any questions? By the way, when it comes to these review sessions, my personal feeling is it's a bit more worth the while to go back to the beginning of the course and review those concepts, because those are the ones we haven't touched in, you know, a couple of months. They're less fresh in the mind. But that doesn't mean that the majority of the exam will be those topics, right? The exam for this class is comprehensive, and there was no midterm, so you should expect the exam questions to be pulled from the entire course in the spirit of equality. If not the effect of equality, at least the spirit of equality. I will be attempting to test all of these areas on the test. Okay? In terms of like grade breakdown, it kind of, any of these questions that result in a coding question as opposed to a short answer question, just because coding questions are kind of chunkier and get more marks assigned to them, they sort of pick up more weight as you go along than, you know, typically short answer questions do. But did I talk about the structure of the exam in this class yet? If you've had a if you have had a class with me, then the structure will be familiar to you. Essentially, the exam will occur in two portions. A little bit like the Java tests, but without the third section. Essentially, you have short answer questions and you have coding questions. Coding questions are, for us, that's a long answer question. For us, that's like what an essay question would be to anybody else, right? So our coding questions will be, you know, on the shorter side, but not, you know, like, normally I try to keep the, you know, I kind of, when I write a question, I almost like write the solution first, and then like write the question for the solution, if that makes sense. It kind of simplifies things to do them backwards like that. But when I do that, like, the piece of code that I'm expecting you to duplicate the functionality of is rarely more than 20, 25 lines of code, right? At least in this course. Java ends up being longer because Java is more verbose, but JavaScript is a bit of a compact language, so you can accomplish quite a bit in 20 lines. So that's the coding part, right? The short answer questions, you can expect a mixed bag. That's kind of like the that's the pick and mix section of the task. You'll see everything from like traditional short answer, here's a question, write me the answer in a couple of sentences type problems. You may see matching questions, you may see ordering questions, you may even see the occasional fill in the blank, although I don't normally do fill in the blanks because they're a bit, you know, elementary school. Two types of problems which I really like in a short answer section are, one, here's a piece of code, tell me what the output is. Can you run the program in your head or on paper? If you can't do it in your head, do it on paper, right? It's kind of like trace the program. Did they teach you how to trace programs, hopefully? You know, to make the table and everything? All right, maybe that's something we'll talk about today as well. Let's see, any other essential skills for a programmer that we need to cover in this one review session? Another type of problem that I really like for a short answer section is, here's a piece of code, show me where the bugs are, right? So code analysis, I consider to be kind of in the short answer section, even though you could, you know, it's not exactly a knowledge question, right? Kind of more of an application question, but, you know, still, short answer. Let's see. Anything else? Lately I've been doing a type of question I call table questions. Like, if it's like compare and contrast, like give me a point for and a point against these two things, I'll just like put an actual table on the exam and give you spot in the table to write the answers. I've been doing those a little bit. I'm kind of experimenting with the with that question type. I think it's a good one, but you know. So yeah, like compare and contrast are kind of traditional question types for a section like that. Particularly because, you know, we are working in a technical profession. One of the things that I think constitutes like real, like part of like the real knowledge that you need to succeed in this discipline is an awareness of the trade-offs, right? You need to know in what situation is this solution good, in which situation is this solution bad, what are the alternatives? You need to be able to like pick one thing versus another intelligently and according to their strengths and weaknesses, right? So that's why I like that type of question. Okay, any questions about the questions? Okay, sounds good. Shall we, I got a lot of confused faces when I said trace a program. So I'm going to show you now a quick example of tracing a program. This will be a very quick example. A program. This is how you perform a program trace. All right? You make yourself a table, and you give yourself one column for each variable in the program. What variables do we have in this program? Anybody? I is one. What's the other one? Sum. Good. So, what you do is you kind of keep your finger here, or you can like draw little arrows, but you're going to have to go back through, so like this is something you do with your finger, right? You start at the top, and you just compute what the program is doing on paper. This is what tracing is, right? So, on this level, sum is equal to 0, sum is equal to 0. For let I equal 0, I is equal to 0. I is less than 5. Is I less than 5? Yes. So we run the loop. Sum plus equals I times 2. What is I? What is I times 2? So the new sum is, there we go. Now, back to the top. I plus equals 2. So what is I? What is I plus 2? 2. We then continue. Sum is equal to I times 2, or sum is plus equals I times 2. What is I? What is I times 2? What is sum plus 4? Not trick questions. We are finished. Go back up to the top. I plus equals 2. You guys are probably getting the idea by now. That becomes 4. Is 4 less than 5? Yes. So we keep running the loop. Sum plus equals I times 2. What is I?
4.
What is I times 2? What is sum?
4.
What is 4 plus 8? 12. Very good. Finish the loop. Go back up. I plus equals 2 gives us 6. It's very important when you're tracing a program, don't skip any steps. The thing you are trying to do when you're tracing a program is execute every statement that the computer is executing. You are becoming the computer. This is your program, and this is your memory. If it doesn't get here, it's not in your memory. Right? So, is 6 less than 5? No. So we exit the loop, return sum. This is the value we, oh, no, what am I doing? Good thing. That's the value we are returning. Right? So, question. By just reading through that, did you automatically get that the output would be 12? No, that's like an impossible thing to ask a human to do, right? In order for us to be able to calculate that, we have to run the program. Make sense? So that's what tracing means. It's essentially just, I'm running this program on paper. I personally think that tracing programs is extreme good programming practice. Basically, over the last, number of years that I've been teaching, it's been kind of like a question in my mind. How do I get someone to be a good programmer, right? What do we do? What's the thing that you need to be able to do to be a good programmer? And I believe it's that. That is what you need to be able to do. But you need to be able to do it routinely without really thinking about it. Computer languages are similar to spoken languages, right? How many of you in this class are multilingual? Probably a fair number of you. Yes. So when you're learning a new language, right? You go through this phase where you are not fluent. And when you're not fluent, perhaps your experience is different, but this is mine. You're essentially taking everything you're trying to say, translating it into a language you do know, processing it in the language you do know, then back translating it into the language you're speaking with someone else, right? And the reason that you're not fluent in the language is because that translation process takes time, right? That's why you end up kind of halting with your speech, right? Once you have enough experience in the language, you can achieve fluency, which basically skips that step. You don't have to translate back into a language you know well. You know the language you're speaking well enough to be able to think in that language directly, right? Everyone in the room should be attempting to achieve the same thing, but with computer programming languages. You want to be fluent in computer programming code, right? Now, fortunately, once you've achieved fluency in one language, you've basically achieved fluency in all of them, right? Although, in class we focus quite a lot on the differences between Java and JavaScript and Python and PHP and all of these languages, really they're much more similar than they are different, right? That's really quite true. It's strongly true. They're much more similar than they are different, at least in comparison to any other group of languages that you might be learning, right? So that is your object. You are trying to achieve fluency in computer programming code. Now, what does it mean to be fluent in computer programming code? It means not taking this and translating it into something else to think about it, right? If you're taking this and you're translating it into, for example, English to think about, you're not going to be a very effective programmer. This is kind of the category of test solutions I get where people are actually mixing English language words into programming code, right? Whenever I see that, I'm like, oh, well, this person is, it is unfortunate, but this person is probably not going to pass this test because, that would not compile, right? You can't just describe what you want the computer to do and it does it, right? Not yet, anyway. AI. I don't think AI will ever really truly reach that point, actually. Like, there will always be a need for expert programmers, because unfortunately, the AI makes mistakes, right? And it doesn't always give you what you ask it for. So, that's what you're trying to achieve, is you're trying to be able to think as the computer thinks, right? So to think as the computer thinks, you must think in terms of short statements and memory operations, right? You must be able to think to yourself, I need this to happen from that. This is the operation that does that. I write that down and boom, I have a program. But breaking a calculation down into all of its tiniest little chunks, that is how you program. You must think in terms of these basic operations, right? Does that make sense? I sometimes call this point of fluency, I call it the click. It's kind of the point at which two gears start to mesh and turn together. And you would be surprised how quickly you can program once you have learned fluency. Once you've achieved fluency, you can program literally something that used to take you, say, 4 to 6 hours might take you 20 minutes. That's what the gain is on becoming fluent in computer programming code, right? Because I am an old man and experienced in programming, I can write a program that I set for you guys to write, I can usually crack that out in about 15 minutes, Like any assignment that you guys had this semester, I could probably, well, with the exception of assignment 4, because it kind of, I would probably be inclined to do something a little fancy, right? But if I was doing a basic implementation of assignment 4, I could probably crack that out, 15, 20 minutes, right? I aspire that everybody in this room should be able to do the same, but it takes practice. It takes practice thinking like the computer. That's why I think tracing exercises are so important. Make sense? Okay, I'm sorry. We'll continue. Although I do think that was so that's not recommendation number 1 I have for doing stuff on the exam or in programming in general. You should be able to trace a program. That is a skill you should have. The other thing is, and this is probably going to come into it more in later semesters when you start working more with data structures, but when you are working with data structures, draw them. Draw them out on paper. If you have an array and you're trying to design a program to work on an array, draw the array, put some numbers in, and do the thing you're trying to do on paper in your head. Then write your program. You won't understand the algorithm you're trying to write unless you've done it. It's either so dang simple that you can just crack it off like that, or you've gone through it once or twice to understand how it works, and then you can write the program. Does that make sense? Okay. Variable scoping. So let's talk about functions. Functions. So, I'm particularly talking about anonymous functions, right? Functions in general, you know from Python, so, we don't really have to talk about just functions. So there are two ways of encoding anonymous functions in JavaScript. This is one. Right? This is the other. Both of these do almost the same thing. Almost the same thing. This guy, I sometimes refer to this as being the anonymous function. The difference between this and a proper function declaration is you're simply missing the name of the function being declared. In JavaScript, you can assign an anonymous function to a variable, and that's actually, semantically, the same thing as like putting f here, right? That's equivalent. This is often called an arrow function. If you wanted to term it more exactly, you would call it a lambda, right? But essentially, if I put something like this in, 5 arrow 5, or x arrow x plus 5, this is now a function taking one argument, adding 5 to it, and returning the value, right? So ordinarily, these are preferred when the thing here is an expression and not a statement, right? Like an if statement, for example. Putting an if statement in here, you can do it, but this one's kind of better set up for it, right? You already have the curly braces. It is possible to do a lambda with curly braces. That's a thing you can do, right? But, it's a little clunkier, in my opinion. So, here is the one actual difference between these two. You remember variable scoping? You remember function level variable scoping? This counts as a function. This does not, with respect to function level variable scoping. So this thing, very similar to the function, except you don't get a new variable scope with it. Whereas this thing does create a new variable scope, and that's the difference. Ha! You were wondering all semester what the difference was, right? Now you know. So, any questions about functions? All right. So let's talk event-driven programming. Well, actually, before we get there, maybe we should talk about document object manipulation and structure. So, all right. How do we get a reference to a DOM element in JavaScript? Document dot query selector. Good. Document dot query selector. If I put an all on there, what does that do? Sorry?
All the elements inside the bucket.
All of the elements matching the query, right? So the input to query selector is a CSS query string, right? So if you wanted to grab everything with the class old, right? Query selector would get you the first match and only the first match. Query selector all will get you an array, or well, in JavaScript it's a list. It will get you a list of all of the elements matching that query. Make sense? Question? What's wrong with get element by ID? What's wrong with that? Why do we not want to use it anymore?
I think because it gets only the elements with the ID.
Sorry, can you say that a little louder?
It gets only the elements with the ID assigned in it.
Yes. For one thing, it's less flexible, right? It's easy enough to turn this into get element by ID. All you use is our good old friend, the octo form, right? Now, you may not be aware of this, but there's actually a family of similar methods here. You also have things like get element by class, get element by element. There's a whole suite of these things, right? Now, they're basically just, between all of them, they do what query selector does. But they're just less flexible, and you have to remember all of the method names instead of just one, right? It doesn't integrate into our existing CSS way of doing things. So get element by ID is not encouraged. It's not considered like good current practice. That being said, you will still see lots of it. It is so well ingrained in the current and existing code base that, you know, it's a bit of a turd that won't flush, this guy, you know. So good. So to the structure of the document object model itself, then. The document object model is a tree. The root of the tree is always an object defined in JavaScript called document. Essentially, every node in the tree after that is an HTML tag. So, HTML, head, body, maybe head's got a script, maybe body has an H2, a div, and 3 paragraphs. It is actually possible, using document, to walk this tree. Every node has an array of children. So the 0th child of document is the HTML element. The 0th child of HTML is head. The first child of body, or the first child of HTML is body, right? You can walk through the document object model using just direct references from document. But it's a terrible idea. It's a bad, bad, bad idea. And the reason it's a bad idea is, what if somebody inserts something? Right? If you have said something like document, not to mention it's also just very long, document.children at 0, children at 1, children at 1, right? First of all, what element is that?
The div.
It's the div. It is the div. The div right there. That's what it is. Now, here's a question. What if I scooch in a little nav bar right there? Well, this ain't 1 anymore. This becomes 1. That becomes 2. Does this target the same thing? No. This is now targeting the nav bar, which will be a problem because this code has been written assuming that this is a reference to a div containing paragraphs. It's no longer a div containing paragraphs. It's a bloody nav bar. So, your whole code breaks. It shatters like an expensive vase. That's the reason you don't do that. Direct references will be broken anytime the page changes. And remember kids, the page changes not only because of HTML designers putting HTML in it, the page changes from JavaScript as well. You could be the person who's screwing up your own references. This is why we use search functions, right? This is why we use things like query selector or get element by ID. We get ourselves away from relying on the structure of the document object model to be able to find things, right? Make sense? Good. Document object model. Very good, very good. Document object model. So, in JavaScript, broadly speaking, we are doing event-driven programming, right? This is very different from Java, right? In Java, except for that little bit where you're doing the GUI stuff, like right in towards the end of Java, right? Right in the middle somewhere, there's a unit on doing event-driven Java. But in general, when you're programming Java, it's like, I start here, I go doop, 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 done. It's sequential programming. JavaScript, pretty much everything you do will be event-driven in some way, because JavaScript is attaching itself to a document. That document has a user interacting with it. The whole point of JavaScript is to enable user interaction. It's not to be a program in and of itself, right? So, with JavaScript events, we set them up so that they trigger when certain conditions are met, right? To set up an event, we need three things, in fact. Three things. What three things do we need to know in order to set up a JavaScript event?
Add event list.
An event list?
Add event list.
Well, that's the function name. I'm talking a little bit more conceptually. You need three pieces of information. Anybody care to guess? Well, what's the function that we use to create the event? Let's start there. Or the method. What's the method we use to create an event? Come now, there's an exam coming. You'll have typed it several times guaranteed. Starts with an A, D, D, E.
Add event list.
Thank you. To use this thing, you need three pieces of information, right? You need this, you need this, and you need that. Right? What is this?
Object.
An object, not just an object, a special type of object. Has to be from the document, right? At least for the types of events that we've been using here, right? So, one, we need a reference to the DOM. We need an object in the DOM that we are attaching this event to, particularly if we're talking about mouse events, because, objects that we just create in JavaScript, they're not on the page, they don't have position, you can't click on them, right? They're abstract, they're just variables, you can't click on a variable. Number two, what goes there?
Is it like the mouse event or like the
Yes, the event type. And that is a string. So in the case of mouse events, you've got things like click, mouse over, mouse out. By the way, there's no hover event. It's mouse over and mouse out in combination that cause hover functionality. So, okay? Oh, I should say though, or window. Window is also somewhere you can attach stuff usefully. 3. What is 3?
like the function perform?
Yes. This is also called a callback function. Very good. So, when this object has this condition happen, this condition is met, it runs this function. A common pitfall is calling the function here rather than simply defining it there. Make sense? Good. Again, this is something that you will have done many, many times throughout the semester. Okay. So how about timing events? Timing events require two pieces of information, right? But they're somewhat different from these guys. Does anybody remember what the two timing events we talked about in class are? Set interval is one of them, yes. So we have set interval and set timeout. Very good. The first argument to both of these is, again, the callback function. Right? The callback function is the function which executes when this timing event triggers. So what is this blank? What is 4?
Like the amount of time?
The amount of time in milliseconds. Time in milliseconds. Yes. So, set time out is a one-time timer, right? You can think of it as a, like an egg timer, right? Set interval is a repeat timer. It repeats every X number of milliseconds. You can think of that as your recurring meeting setting. Or perhaps that's your, I have to go to class alarm on your phone, right? Everybody has one of those, right? I have to go to class alarm. Aside from that, it is correct to think of these things as events in the regular sense. They are processed by the event processing engine. The only thing about them, they are not attached to the DOM. They are just sort of floating in the JavaScript. So if you want DOM references inside of them, you have to go get them. Make sense? Any questions? Okey-dokey. Good. Well, it's currently 10:30, so I think we should probably break there for a 15-minute break. It's a good time to break. Please be back in class by 10:45. Thank you. All right. So, in the course of this stuff that we were talking about, I kind of think that mouse events have been covered. They are not substantially different between regular DOM objects and SVG objects. The only difference is the type of the thing they apply to. There's not even really a difference in the syntax. So, good. So what do we have here? Well, what do you guys want to do? I've talked for like half the class. What do you guys want to do?
SVG.
All in favor of SVG? All opposed? Very good. I see that you saw you made that proposal without having first secured the support of the entire committee, but it seems to have worked out in your case, so we'll go with it. All right, SVG. So, how do we create SVG objects? Well, it's very simple. Just like that. All right? We designate an SVG region within the document, and there, inside there, we can draw things very similarly to how JavaFX works. Do you guys know why JavaFX and SVG are so similar? It's because it's actually the same engine behind both. That's why they're so similar. So, with SVG objects, there's like a handful of them that you should be familiar with, right? Circle, rectangle. Like you should know how a line works, right? Line and path. I would say those are the important ones. Everything else is stuff that's like, superfluous, you can look it up kind of territory. So it's also important to know what the primary attributes are of SVG objects. How do I control the position of a circle? CX and CY, right? Which stands for center X, center Y. How do I control the size of a circle? R for radius, right? Then, of course, for all of these, you have things like fill, stroke, line width, all of the stuff that you hopefully remember from JavaFX, right? Now, for rectangles, how do we control position? X and Y. That's right. X and Y. How do we control width and height? Well, it's just width and height, right? I think so anyway. Correct me if I'm wrong. Thank you. Now, here's an important thing, right? If you just close an SVG object like that, that's a syntax error. SVG is more strict than HTML. If it's a single tag, right? If it's a tag with no content, you must include the closing slash, right? Without that, it's a syntax error. A minor one, but enough to make the whole thing work, right? It's like forgetting a semicolon. Except, of course, any proper language will tell you you've forgotten a semicolon. This thing will just fail to load anything past that point. How do we control, yes?
You said closing the tags, we made a slash. So in the exam, if we made the mistake of no adding the slash, is that going to be a reduction of mark?
I would consider that to be like a half mark off. kind of territory. Like, it's a minor error. I'm not going to take a half mark every time you do it, right? But forgetting that is worth a half mark off, in my view. For line, how do we control the position of a line? If my memory is serving me, it's something like x1, y1, x2, y2, right? Yeah. Paths are slightly more interesting, right? I believe the option is D, the attribute is D for a path. Don't ask me why. Maybe it stands for draw this, I don't know. But paths are a bit of a separate topic. Once you are inside of a path, the whole point of a path is that you can draw lines in a less clunky interface, right, and group them together. Also, pathing allows you to do curved lines. Now, I'll give you a freebie right here, right now. I am not going to ask you to draw curved lines on the test. All right? Is it a good thing to know? Yes. Am I going to ask it on the exam? No. They are confusing. And people mess them up. And it's the sort of thing that you would look up reference for. Right? But straight lines you should be able to manage. All right? So, there are a couple of important commands. You should think of a path as being composed of commands, right? Does anybody remember what M does? Move to. It takes X and Y. So, for example, move to 10, 10, right? How about L? L is line, good. L, 20, 10, sure. How about H? Technically, you don't need H if you have L. H is horizontal, V is vertical, right? And does anybody remember what Z does? End. So what Z does is it draws a line back to your start point. So, the difference between M and L, you should think of it like you should think of path drawing as I have a pen, I put it down on the page, I move it so far, now I move it this far, this far, this far, lift pen. M is move with pen lifted, right? So it's like move, right? Or to do it on the actual board. If I have a path, like, let's say that this is 30 by 30, right? If I move to 10, 10, then line to 20, 10, line to 20, 20, line to 10, 20, Z, right? Once again, this kind of comes down to, can you, can you run the program? Can you follow these instructions? So, paths always start off at 0, 0, right? So, I move pen lifted to 10, 10. Not to scale. Now, line 2, 2010. This is 2010 right here, so, right? Now, line 2, 2020. 2020 is right there. Line 2, 1020, 1020, and Z is return to start. So we have ourselves a nice little square. Make sense? Good? Not that I've decided what the exam questions are going to be. I'm actually in the process of writing the exam as we speak. Because it's a paper exam, in theory, I could have you draw something. Bring a ruler. Not saying I'm going to do that, but yeah, no. Bring a ruler, just in case there's a question on how to do that. Okay? And people say I don't give hints. I give hints. All right. Does that make sense? Summary of basic SVG stuff. All right. So, let's review the procedure for animating such a thing. So, there are two approaches you can take to animating SVG things. In the first place, you can apply style attributes to these. CSS style attributes. To the extent that you have used style attributes in your SVG graphic, you can use CSS animation to animate those properties. So that's style number 1 of animation for SVG. Make sense? Style number 2 is to use JavaScript. So, in JavaScript, if you have a reference to one of these objects, which you can get using DOM manipulation, right? Let's say, just for the sake of argument, oh, and you can apply IDs and classes to these as well, right? Let's say we have document dot query selector circle. There we go. We have a DOM reference to the circle object. All you really need to do in order to animate something is to modify the property over time, right? Or modify some property over time. So, because that's what animation is. Animation is the modification of a visual property over time. So in order to do that, you need to know two things. You need to know A, modify property, and B, over time. You need to be able to do both of those, right? Modifying properties is not substantially different from how it works with regular DOM objects. There's only one difference. In regular HTML objects, attributes are loaded as attributes of an object, right? You can just say, you know, p.innerHTML. .innerHTML works because the paragraph is part of the HTML base description, right? Every browser knows how to work with HTML. Browsers don't load the SVG definitions by default. So you have to use a slightly different method, which basically JavaScript gives you getters and setters for these values, right? So c.get attribute r, let r equal, there we go, right? This line of code gets the circle's radius and loads it into a variable in JavaScript. So far so good, right? As we can see, not substantially different from c.r. All we're doing is we have to call that method, right? We then perform some change. Perhaps r is equal to r times 1.01, making the radius 1% bigger than it was before, right? Then we write the new radius back in, because this is a variable representing something we've read. It's a little bit different than how you would work if it were like a direct attribute of an object, right? With a regular DOM object, you would be able to do something like c.r times equals 1.01, and you'd call it a day. You'd be able to do all of the operations in that one line of code. But because we have to go through the methods, it takes a little longer and it looks a little bit more like Java, which is actually not a bad thing. Java is a good language. C.set attribute r, and then you provide the value as the second argument. So, there you go. Read existing property, modify it slightly, put it back. That's one way of modifying an attribute. The other way of modifying an attribute is to skip this step entirely, have the value that you want represented only as a variable inside of your JavaScript, and then write the value of that variable into the SVG. You skip this step if you just keep the radius. You have to initialize it as a constant at the top, but you can skip this step if you've done that. This is kind of like better programming in a way, because this is doing model view distinction, right? Your variables in JavaScript become the model, and the SVG becomes the view, right? Because all the view is doing is it's just a view of the data, right? It's not, we're not assuming that we're using the SVG for data storage anymore. We're doing that in JavaScript, right? It's a bit cleaner, it's a bit nicer, it's a bit easier to work with. But I'm not going to be picky on the exam, right? So, there were two things I said we have to do in order to animate. One, be able to modify properties. The other is we have to do that over time. That's right. So doing this over time, how do we do things over time, repeatedly over time? Set interval. That's right. So we take all of this, wrap it in a function, wrap that in set interval, and then we choose how fast this thing is supposed to run, how fast this thing updates. Now, does anybody know off the top of their head how many milliseconds 60 frames per second turns out to be? It's about 16.6. 16.6 milliseconds gets you approximately 60 frames per second, which is, as we all know, the correct frame rate for animation. It's not cinematic, it's good. Does this make sense? So that's how you do animation. It can get a lot fancier than that, obviously, right? At a certain point, like, the fanciness you can do with this will increase to a certain level, it'll plateau, and then after that plateau, you need trigonometry. You need trigonometry to get any further, right? You need sine and cosine, and you need to be able to calculate angles and hypotenuses and all kinds of stuff. For example, let's say you have a planet and you want it to animate in a circle around some other object. How do you do that? Answer, trigonometry. You simply say, well, not theta, but time. If you make the x component into the cosine, if you calculate the cosine on the time, and you calculate the sine on the time and assign that to y, your object will move in a circle around some point. Then all you have to do is offset it with x and y of this. I guess that would be x2, y2, x2, y2, and then you would have some kind of a, which would be that distance, and that's how you do orbit. Yay! Circular orbit, anyway. Don't ask me how to do elliptical orbits. Probably that, actually, but you just have two different amplitude constants, right? Then you could get an elliptical orbit. Or at least a squashed one. Anyway. Enough about orbital mechanics. We're trying to review JavaScript. But yeah, trigonometry is cool. Math is cool, guys! Did you guys know math is cool? Did you know that I'm a registered mathematician? It's true. Now, there we go. We actually stand a pretty good chance of getting through most of this material. That's not bad. So, just to round the topic off, let's talk about object creation and destruction. Now, it's important to understand that object creation and destruction is not only something you do to SVGs, right? It's also something we do with regular DOM objects as well. But the manner in which we do that is a bit different in both cases. In both cases, though, we follow the same 3 basic steps. Step number 1. Does anybody remember? What's the first thing you have to do in order to create a new object dynamically in JavaScript?
Document.create element.
Yes. So we have to create the object. What's the second thing we have to do? We now have an empty object. What do we need to do with it? Sorry? Modify it, yes. Set attributes. And 3, what do we do?
Add it to the DOM.
Add it to the DOM, yes. Very good. So this works slightly differently in SVG and HTML. So, in HTML, the method is the one that you said earlier, right? We want document dot create element. What goes in the parentheses?
Tag.
The tag, yes. For SVG, does anybody remember how we do this slightly differently? Document dot create element ns. Right? The first argument you provide is a URL, which I won't make you memorize for the exam. And then the second one is the tag, same as the other one. So basically, with create element ns, the reason it's necessary is that browsers don't load SVG definitions by default. You must go out onto the internet and get the definitions and load them. Capici? Okay. Number 2. Modifying attributes. This is, of course, in regular HTML, hopefully everybody's, done this enough that you know how it works. Tag.attribute is equal to value. Right? You simply assign to the attributes of the object. Make sense? And we've actually already reviewed this for SVG. Here. Oh, ooh, wait, whoa. I forgot a bit. You got to assign it to a variable, my dudes. There we go. That's better. like that. Question?
For these like X dot attribute, would it be like X dot style? Like that sort of thing?
Only if you're modifying style attributes. But yes, if you're modifying something like background color, then you would, all of those are collected up under style, right? So it would be X dot style dot background color, etc., right? But what if it was an image's source, right? It would just be image dot source, or whatever the variable's name is. You wouldn't go through style for a source or an href, right? Or a link rel relationship, or any of those other attributes. Make sense? Yeah. Style is just for style. Good. Good. I'm really happy that people are asking questions. Number 3. It's the worst 3 in the world. There we go. Basically my curly brace drawing part of my brain kicked in. So, in both of these cases, attaching it to the DOM works the same now in both cases, right? In fact, I can just in both cases, object dot append child x. If you don't do this last step, it isn't actually added to the web page, and it therefore will not show up. Make sense? Questions? Very good. For practice before the exam, I recommend working through some code examples of doing that, right? So, the sorts of things that lend themselves nicely to coding questions. Things like mouse events and timing events. That makes a good coding question. Ajax makes a good coding question, although that also makes very good concept short answer questions, right? Those would be like everything in this sort of area, that would be good coding question. And by the way, for SVGs, simply write out, here's a picture, do an SVG that, try to interpret this as an SVG. I consider that a coding question, even though it's kind of like HTML. Is that really code? It's like, well, it looks like code, even if it isn't code, so I'll put it in the coding question section. Anybody who was happened to be around for the for last semester's exam may remember a question like that on last semester's exam. Object creation and destruction, that's like a thing that I could ask you a coding question on. DOM manipulation is kind of like, it's sufficiently necessary for everything else that you probably won't see a question on it specifically, right? Because it's kind of baked into most of the rest of them, right? Does that make sense? With respect to Bootstrap and CSS, less likely that there would be a coding question on that. Conceptual questions, sure, right? Absolutely. But like, the thing about Bootstrap is it's kind of like, here, memorize a bunch of Bootstrap tags and apply them, you know? It's important to know how they kind of work in general, but like, you know. Yeah. Make sense? And then, it should be fairly obvious that, these types of topics kind of lend themselves more to short answer, right? Like, variable scoping, if you're getting to define your own variables, then, I'm going to assume that you're doing your own variable scoping. So if I'm testing you to see if you understand variable scoping, it's not with a coding question, right? It's with, something a little more direct and pointed. Make sense? Okay. Do you guys want to do Bootstrap / CSS next, or do you want to do Ajax?
Ajax.
Ajax? I'm hearing an Ajax. Anybody else for Ajax? All in favor of Ajax? All opposed? Very good. The unanimous consent of the board. All right. Ajax then. One thing I will say about Ajax before we get started. To send stuff by post using Ajax requires quite a lot of, kind of memorization of that header content type X www, that thing, application data, that line. If there was no cheat sheet, I wouldn't expect anybody to get that right. Let me hang that in there for just a moment, right? So, maybe when you're considering what to put on your cheat sheet, an example of how to do a Ajax post request might be a thing that you might find useful. All right? Not that I'm saying there will be a question on that. Just, keep it in mind. That's, kind of quite sincerely though, that is precisely the sort of situation where a cheat sheet is useful, right? For a code example, because it's you kind of have to remember the structure of it. There are a bunch of options that you have to set that you won't necessarily remember all of them. It's a good thing, kind of, in general for a cheat sheet. It's the same sort of thing that you would put up as a quick reference sheet in your office, right? And that's, by the way, that's another piece of advice for becoming a better coder. Make yourself a quick reference sheet. Don't go and get one off the internet. Make yourself a quick reference sheet, print it off, hang it up wherever you do your work, right? And that way, when you're working on your problems, you don't have to, pull up the browser, break your flow, and look something up. You can just say, oh, I forget this. Oh, there it is, okay. Right? Quick reference sheets. Time-honored tradition inside of the coding arts. Yes. So Ajax then. Within the unit on Ajax, we talked about various data formats, most particularly JSON, right? Can anybody tell me what a JSON is? Yes, JavaScript object notation. Very good. So JSON I thought they were coming for us for a moment. You're not allowed to talk about JSON. So what JSON is, right? At the top level of a JSON, you have either square braces or curly braces. Does anybody remember what the square braces are? A list. Yep. List. Does anybody remember what that thing is?
Alright.
Not an array. You're in the right ballpark, though. Not a string. JavaScript, blank notation. These are objects. So it's important to understand that objects in JavaScript are not really like objects in Java, right? Objects in Java are nice and pleasant, and you can type check them, right? An object in JavaScript is basically an associative array that you can attach methods to, right? That's what it is. It's a mapping that you can attach methods to. JavaScript very much thinks of the data in an object as the primary thing, and methods as a thing that you stick on the side. So, aside from lists and objects, the other sorts of things that can be in a JSON are all of your regular primary data types. You can have integers, floating point numbers, booleans, strings, and you can also have null in there, which is kind of like the void type literal, if that makes sense. So a JSON is a nested hierarchical structure made of those things. Any spot in a JSON can be occupied by any of those things, right? So everything from your simple and humble array of integers, that can be JSON encoded, and something very complicated involving lots of things that I don't have the time to get into because this is a review and time is short, that is also a JSON. Now, it's very, very important to understand JSON data is a string, right? It is a format for string data, right? It's a way of taking all kinds of lovely programmy stuff, all kinds of variables in your program, and dumping them into a string, primarily for the purpose of sending over an HTTP connection, right? If you want to send data to the server, you encode it as a string, and then you send it. The server receives it, decodes it, does something with the data, repackages it as a string, and sends it back to the client, who catches it, decodes it, does something with the data. Right? But the trick is, when things are traveling through the internet, it has to be a string. It must be a string when it's passing through the network. Does that make sense? So there are two important functions. JSON.parse. It turns a string back into data, like native data, and JSON dot, and this is the worst method in the world, dumps, or dump string. It's, I don't know why they call it dump. It's dump. In JavaScript, those are the methods you use to take a JSON and turn it into data, or take data and turn it into JSON. Make sense? Good. So let's talk about Ajax. Well, let's first review get and post. So, what's the difference between a get request and a post request? Anybody? Difference between a get request and a post request? Sorry?
Post is encrypted.
Post is encrypted.
Encrypted.
Yes. Post is encrypted
Okay.
and get is not. Is that what you were going to say?
Yeah, I was gonna say like, the get is in the URL, so it's not encrypted.
Yes. The get parameters are in the URL, so it's not encrypted. Good. Yeah?
You give a stored in the data.
Yes. Well, in
Stored in the data.
yes. Yes, the post parameters are stored in the payload. The payload is encrypted, so post parameters are secure. Get parameters are not stored in the payload, they are stored in the URL. So why would you ever want parameters sent that weren't secure? What is the point of a get request? What can it be used for that you can't do with a post request? Linking people YouTube videos. You can't share post data. You can share get data, right? Because it's in the URL. So all you have to do is copy the URL, paste it into your Instagram post or whatever it is, and boom, you have linked to something else on the internet. So generally, posts will be accessible by get. But things like, sending your credit card data to a company, you better hope that's post encoded. Right? Sound good? So, what is the point of an Ajax request? Well, in general, we have discussed 4 ways of connecting to a server using a browser so far in the program. The first, your kind of point of entry, is the URL address bar, right? We enter a URL, it takes us to the site. We request that page, it pops up. Good, that's 1. 2, clicking links. When we click on a link, it is functionally the same thing as entering that link's URL, putting it in the address bar, and clicking on it, right? Number 3, submitting form data. The same as clicking a link, but now we're attaching some parameters. With forms, you can choose to send those parameters by get or post by selecting the method inside of the form tag. Okay. Ajax is a bit different from those 3. All 3 of those, by default, cause a page reload. You're trying to load a different web page, right? Ajax does not cause a page reload. The purpose of Ajax, oh shoot, we need to do it. We need to go through it. Did we go through assignment 5? Okay. Okay. All right. I'm just like, Ajax Ajax, that's assignment 5. Oh, did we talk about it? Yes, we did. Okay, good. What was I even talking about? I broke my train of thought. Ajax requests, talking about they don't reload the page. Yes. Ajax requests don't reload the page. They are for a different purpose than the other 3. They are for communicating with the server from within one web page. Therefore, the information that Ajax requests get back is only rarely HTML pages. It's only rarely CSS files or JavaScript files. Most of the time, you're just getting data back. String data, JSON data, maybe CSV data, right? But you're getting some kind of data string back. You're not getting a file. You're not getting something that would parse as HTML, although you might get HTML snippets, right? In general, it's actually kind of a bad plan for the server to send you snippets of HTML. Generally, what should happen, the server should send you data, and then local JavaScript functions are responsible for making the HTML and putting that into the web page. Although that's kind of like, that's one of the finer points of like whose job is whose, right? Let's leave that to the side. So, Ajax. We use it from JavaScript to get more data from the server into JavaScript. We then do stuff with it. Make sense? Good. Anatomy of a fetch request. I always put that C in there. Resource. Fetch. There we go. So, we initiate an Ajax request using the fetch function in JavaScript. The first parameter is the remote resource that we are fetching. This can just be a data file. It could be data.json. Much of the time, in this course and in server side, those will be PHP scripts. Because PHP is what we teach in this program, unfortunately. So, this might be data.json or, script.php. Something like that. After this, you have an object giving you options. If all you're doing is a straight GET request, you actually don't really require anything here. In our case, because we were using CS Unix, and this is for assignment 5, so pay attention, please. For assignment 5, you are putting your assignment in the private folder on your CS Unix account. This means that your Ajax requests must carry the same credentials that you used to access the page in the first place. So you have to say credentials include. This is not necessary if the server is not, if you're not in a password protected area of the server, right? And this is different from managing access levels with sessions. That's something that we'll get to in server-side programming. We have plenty of time to talk about that. If you're doing a post request, this is where you would put things like method is post. Strings. method is post, body is your parameters, right? Do that thing with the header content type, right? Good? After that, you need 2 callback functions to break this out of its promise. Right? Data gets data.text or .json, depending on whether you are expecting back string data or JSON encoded data. Data.json is the same as text, where you call json.parse on the first line of the callback function, right? It's just using json.parse for you. That's all it's doing. Your second callback function is where you actually have the data available to you. Response and then your code goes there, right? Maybe console.log response. Right? Make sense? Any questions? Well, we only have 5 minutes left to talk about Bootstrap and CSS, so I will just quickly tell you a few things which I consider to be useful and important things that we talked about in this class. All right? For CSS, there was a discussion of the sort of extended set of selectors, right? Pseudo classes, attribute selectors, particularly. Things like hover, and the thing where you get to filter your CSS results for things having a particular attribute, right? The traditional example of that is like selecting a particular input type in a form, right? We had a discussion of CSS precedence, CSS selector specificity, right? If I give you 2 CSS selectors and say these are applied to the same object, you get to tell me which of the 2 properties gets applied, right? How do you resolve CSS conflicts? That's important to know. With respect to Bootstrap, it is useful to know how the Bootstrap grid system works. Maybe tables as well. I don't know, it's just really applying styling, you know? Yeah, the grid system is a little bit like, it has a little bit of, you know, like there's some conceptual work there, right? But with, and just a little bit, with like tables, it's like, you know, it's really just styling, you know? It's like, oh, you know, write me a Bootstrap label that makes this table striped. Okay, table dash striped. Is that a test question? I don't know. I don't think so. Deep breathing. You can do this. It is possible to pass. You just need brain, and you need the test. You need to use your brains on the test. Make sure you have a good breakfast the day of the test, right? Make sure you don't run out of energy halfway through the test. That is a terrible test writing strategy. Do not imagine that caffeine is a replacement for studying, right? Just like if you have a caffeine addiction, and you will have a very bad headache if you don't have your caffeine, then have your caffeine before coming to the test. But don't imagine that downing 4 or 5 energy drinks before the test is going to be a suitable replacement for having studied. All right? You have enough time before the test to do some good, proper studying. Good, proper studying is a bit every day. It doesn't have to be long. 15, 20 minutes every day, and you'd be surprised what you can get done. All right? Once again, my recommendation, 15 to 20 minutes a day, go through a section of one of the course notes, read it through, all right? Process it in your brain, do some code examples to understand what you've been reading. Then, the next day, write a summary of what you did yesterday. You're trying to pack things in your long-term memory, not your short-term memory. Cram if you must, but understand that proper studying will do you much better. Cramming is better than not studying, but studying a little every day is much better than cramming. When you're studying, build recall into your studying practices. You are not being tested on reading. You are being tested on remembering what this course was about. All right? Yes?
On the modules, there is an exam review.
Yes. I have an exam review document. I'll publish it sometime today once I get back to the office and I have some time at my computer. Yes, there is a review document. I will be publishing it. Yes. Good. Any final questions? All right. Well, in that case, I wish you a hearty good luck on not just this, but all of the exams that you may have this semester. And I hope to see you all in the fall for server side.